Our next example from section 7.3 starts with a matrix that has some characteristics similar to one of the earlier examples, but let's apply Gaussian elimination to this, and we'll begin as usual, operating on row operations involving the rows 1 and row 2 from the previous matrix. So we'll start off, row 1 stays the same. And to get the -2 in the second row to disappear, the combination of row operations that will work is our new row 2 will be the original row 1 plus row 2 from the original matrix. So that means 2 plus a -2, or 0. And then we have -2 plus 3 giving us a 1. Then we take 1 plus -1 and get 0. Then we take 3 plus 1 and get 4. And now we don't need to operate anything on the third row at this point. We just copy it over directly. And now we're ready for still one more step to try and get rid of the 2 here on the bottom. So we'll copy the first 2 rows down. But now to get rid of the 2 in the last row, we're going to take a combination of rows 2 and 3 and operate off those. So we're going to take -2 times row 2 plus row 3, and that'll be our new row 3, and that gives us 0. Then we take -2 times 1 and add 2, and we get 0, which is what we wanted. Then we take -2 times 0 and add 0, and we get 0. Then we take -2 times 4, and we get -8 plus 8, and we get, whoops, a big fat 0 row. So does it look like we can solve this? You might think no, but the truth is that we can solve it. We just won't be able to solve it for a unique solution. What is this matrix actually telling us? It's telling us in this form, that x2 is equal to 4. We know that just from the second row. But from the original row 1, we know that x1 could be written as 3 plus 2x2 minus x3, all divided by 2. And because we know that x2 is equal to 4, we can now say that x1 is equal to 3 plus 8 minus x3 all over 2, or x1 is equal to 11 minus x3 over 2. What does that say? That tells us we have an infinite number of solutions. All of these solutions lie in the plane of x2 is equal to 4, and all the solutions lie along the line defined by this equation within that plane. So we have an infinite number of solutions, because as you probably could have seen at this point, once we got to that point, you can see that row 2 and row 3 are just a integer multiple of one another. So we really didn't have 3 equations and 3 unknowns. We really had 2 equations and 3 unknowns. So we were never going to be able to find a unique solution. In this case, we found an infinite number of solutions. And that's it for example 4.